Imagine a world where the stress of choosing what to eat simply vanishes. No more calorie counting, no more guilt over that late-night slice of pizza, no more worrying about chemical additives or nutritional deficiencies. What if every single meal you consumed was mathematically perfect, a flawless delivery system providing precisely the amino acids, micronutrients, and energy your body requires at that exact moment, tailored down to your individual DNA? This is not just science fiction. This is the ultimate promise of advanced 3D food printing. We are moving beyond printing plastic toys and housing prototypes. We are heading toward a future where food is synthesized from molecular compounds, customized to you, and printed fresh on your counter. But we have to ask the critical question: if we achieved the perfect meal, would it solve humanity's biggest problems, or would it simply create entirely new ones? For centuries, our relationship with food has been defined by scarcity, uncertainty, and incredible effort. From hunting and gathering to complex industrial agriculture, we have struggled to feed ourselves efficiently and equitably. The 3D food printer, often called a replicator by its proponents, flips this narrative entirely. In this vision of the future, food production is decoupled entirely from traditional agriculture and geography. Instead of fields of corn or massive cattle ranches, your food is derived from basic nutrient cartridges filled with chemical precursors, protein structures, carbohydrates, fats, vitamins, and minerals. These precursors are synthesized from sustainable sources like algae, insects, or even atmospheric carbon. When you desire a meal, the printer mixes these base ingredients using microscopic nozzles and lasers to assemble the molecules layer by layer, generating the precise texture, structure, and flavor profile of anything from a ribeye steak to a bowl of pasta. The implications for global health are staggering. The most compelling argument for perfect food is its potential to eliminate global hunger and malnutrition. Food deserts become irrelevant. If the necessary building blocks of nutrition can be manufactured locally and efficiently, distribution ceases to be a major obstacle. Famine becomes an artifact of history. Moreover, this system is inherently zero waste. Traditional food supply chains account for enormous waste through spoilage, transportation inefficiencies, and consumer plate scraps. In the 3D printing model, only the exact amount needed is printed. Any unused molecular precursors are recycled back into the cartridge system. We could achieve a truly circular food economy, minimizing environmental strain and maximizing resource efficiency. This is a powerful, utopian solution to some of our most pressing environmental concerns. But the true revolution happens when we look at the individual level, the hyper-personalized diet. Today, even highly customized diets are based on broad population averages. We might take supplements based on a blood test, but we are still guessing. Tomorrow, your nutrition printer could be networked with advanced diagnostic tools. Imagine a wearable device constantly monitoring your metabolic rate, hormonal balance, current blood glucose levels, and even your gut microbiome activity. This data is instantly fed into an artificial intelligence algorithm alongside your complete genetic profile. The result is a meal plan that is not just tailored to you, but tailored to the moment. If you had a stressful meeting, your meal might be augmented with additional magnesium and specific amino acids designed to promote relaxation and serotonin production. If you are training for a marathon, the meal is calculated to precisely rebuild micro-tears in muscle fibers while maintaining electrolyte balance, all based on the exact intensity of your morning run. For people with chronic illnesses, this is transformative. Someone managing type 2 diabetes would receive food where the carbohydrate structure is engineered for maximum slow release, preventing harmful sugar spikes. Allergies become obsolete, as the molecular components responsible for adverse reactions can be easily excluded. Food ceases to be a variable of risk and becomes a predictable tool for optimizing human performance and longevity. It is the ultimate expression of food as medicine. At this point, the perfect meal is less about taste and more about functionality. It is the ultimate fuel for the human machine. But here is where the deeper questions begin to surface. If food becomes merely fuel, what do we lose? The pursuit of perfection often leads us into an uncanny valley of human experience. Food is one of the oldest anchors of human culture, tradition, and community. We do not just eat for survival, we eat to celebrate, to mourn, to gather, and to remember. Consider the complexity of a family recipe passed down generations of flawed, handwritten card covered in grease stains. That recipe is imperfect. It relies on vague measurements, a pinch of this, a dash of that. But its imperfection is precisely what makes it meaningful. The variation, the slightly burnt edges on the cookies, the saltiness that varies slightly based on who cooked it, that is where the memory resides. If every meal is flawlessly engineered and replicated, are we replacing tradition with sterile efficiency? When food is created solely to maximize nutritional output, does it strip away the joy of flavor variation and the beauty of terroir? The subtle difference in soil, climate, and human hand that makes a French wine different from a Californian one, or a homegrown tomato superior to a hydroponic one. That complexity arises from natural imperfection. A replicated apple might have the exact chemical breakdown of its natural counterpart, but does it contain the same sensory narrative? Some researchers fear that a diet of perfectly synthesized food would lead to a sort of sensory and cultural deprivation, where the human palate becomes bored and the rich tapestry of global culinary culture fades into a standardized digital file. And then there is the massive ethical concern of control. Who writes the recipe for the perfect meal? If our entire nutrition system is run by algorithms and proprietary molecular cartridges, food production shifts from being decentralized and diverse into the hands of a few powerful tech corporations. These companies would essentially own the means of human sustenance. If the algorithms that determine our perfect diet are flawed or biased, the consequences are enormous. We become utterly dependent on a centralized technological system. If that system goes down, or if the owners decide to subtly tweak the nutritional inputs to manage public behavior or enhance productivity for specific goals, we have no independent food sovereignty. In this scenario, the perfect meal is not just perfect in its nutrition, it is perfect in its compliance. Furthermore, we must address the psychological pressure that comes with quantified perfection. If we have access to the optimized diet, why would we ever choose anything less? The perfect meal is inherently rigid. It leaves no room for the unexpected craving, the spontaneous indulgence, the pleasure of imperfection. If our nutrition is always being measured, calculated, and judged against the perfect metric, does that turn the act of eating, one of life's great pleasures, into another high-stakes performance metric? The very pursuit of optimization can breed anxiety and a deeper dissatisfaction with anything that falls short of the algorithmic ideal. We have explored the astonishing potential of 3D printed perfection ending famine, eliminating waste, and optimizing human biology. It offers a clear, rational solution to fundamental human problems. But perhaps the perfect meal is a conceptual trap. The concept of perfection itself is often an illusion, a static, idealized state that denies the dynamic reality of life. Human beings thrive on variance and surprise. Our bodies and our cultures have adapted to thrive not in spite of imperfection, but because of it. The best meals in our lives are rarely the ones that were perfectly optimized for nutrition. They are the meals shared with loved ones, the ones that connect us to our past, the ones that tasted better because they were eaten outdoors after a long day of work, or the ones that required immense effort to prepare. They are defined by the human stories embedded within them. If the goal is to feed every human being on the planet efficiently and sustainably, 3D printing molecular food is likely part of the necessary solution. It can be a vital tool in eradicating true malnutrition, but we must resist the urge to declare it the only solution. Because while a computer can print a flawlessly nutritious piece of food, it can never print culture, can never print memory, and it can never replicate the complex, messy, and deeply satisfying feeling of sharing a perfectly imperfect home-cooked meal. Maybe the perfect meal is not the one tailored to our DNA, but the one tailored to our humanity.